Hello friends, welcome back to our YouTube channel. Let's continue our discussion on expressions. Today we are going to see about scopes. Okay, so it did go through it in last class, but today we are going to dive deep into that. So for that, I am today going to teach you create a simple program. Okay, this program what we'll do is we'll try to find the leap years. Okay, how to find a year is a leap year. Okay, so simple thing. What is a leap year? Leap year is every 4 years. In every 4 years, February will get an extra one day as 29th day. So that will happen every fourth year. Correct? So we have to find out, for example, say 2004. Whether 2004 is a leap year or not. So we have to find it out. This program. So how can we do that? So let's see what are the conditions, right? It should be, first condition is, okay, it should be divisible by 4. Okay, so now it is considering start 2004 will be a leap year, 2008 will be a leap year, going forward 2020 was a leap year, 2024 was a leap year. Okay, so it has to be divisible by 4. Okay, and another condition is it should not be a, so that in a year we have 365 days, 365 days, okay, but okay, it's 23.25, so that we add every 4 years one extra day to compensate it. Okay, now but even if you're adding that one, right, what happens is over a period of 100 years you would have added one extra day, because it's not exactly 25, it is 25 plus. Okay, so we would have added an extra day to reduce that. Every 100 day will not add it as a leap year. Okay, so second thing should not be divisible by 100. Okay, it should be divisible, should not be. And third condition, after doing this extra leap year calculation, okay, after we're doing 3 years, the fourth year we're doing this extra day, right? In the fourth year, one extra day is additionally removed. So if it is divisible by 400, we have to add it as a leap day. Okay, if divisible by 400, then it's a leap year. Okay, so if a year is divisible by 4, not divisible by 100 and divisible by 400, even if it is divisible by 100 and if it is divisible by 400, then we are going to consider it as a leap year. Okay, okay. So how to write a program for this? So we have 3 rules, right? So let's consider, let's take an year field. Okay, let it be any field. let it be value of 2004. The general condition. First condition is year modular of 4. Okay, what it will get, where modular of 4, when modular, what is modular? So when we divide year by 4, okay, the remainder, whatever remains right here should be z. Whatever remains here, that is modular. Okay, this is divided by, not modular, this is divided by, here the modular is this side. Okay, it should be equal to 0. Okay, this is one condition, first condition. Second condition should not be, correct. So let's see, here modular of 100 is not equal to 0. Okay, now there is one more condition, right? Here modular of 100 should be equal to 0. If this is not the case, then this should be the case. Okay, to call it as a this one. So let's combine all three. Okay, let's see, this is a basic condition. So this should be it should be validated every time. Okay, now if a year is divisible by 4, okay, and is not divisible by 100, let's consider it as 3. See now, if a year is divisible by 400, it will always be a leap year. Okay, so let's take that condition. It's a by default condition. Modular of 400. So this is the default condition. Okay. Now, if this is true, then no need of checking whether it is divisible by 400, because already 400 is divisible by 4. Though here will by default be divisible by 4. So this is a default condition. If it is divisible by 400, by default it's a leap year. Or what we can say, okay, this is or. We'll read about more about these operations later. Now here you can see, here modular of 4 is equal to 0, always should be 0, and okay, here modular of 100 should not be equal to 0. Should not be equal to 0. Okay, so this is our condition. Okay, let me write it in the above. Okay, so let me rewrite it. So first thing is, here modular of 400, it will be a leap year, or here modular of 4 is equal to modular of 100 is not equal to 0. So this is a single, this one, this is, okay, let me say, let's take an example. Let's take an example. Okay, let me say year is equal to 2004. Correct? Now substitute here 2004. A 400 is not true, it's false. So it's false. So it will go to, from false, it will go to here. 2004 modular of 4. We divide, the remainder is 0. Correct? So this is true. Now let's come to here. Okay. Year modular of 100. So now this is AND condition here. Okay. 2004 modular of 100 is how much? There will be some value, right? So that is not equal to 0. So this is also true. This is false. This is true, true. Okay, as these two are true, the whole value will be true. False. Okay, false or true is always going to be true. Okay, so 2004 is a leap year. Similarly, we can test many things. Okay, now let's consider, yes, 2009. Okay, was it divisible? False. Modular of false? False. Zero? True. But true and false is false. Correct? False or false is always going to be false. So 2009 is not a leap year.
So here I have created a leap year program. So in this program, I'm going to do, so I have included the studio.h. I have declared a global variable. I have declared the function to check the leap from. I have the main function and I have the check leap year function. Okay, so let's go to what my main function is doing. Main function is doing, what is doing, it's taking the year, it's asking for a year, it's scanning up, updating the year, storing it into the year. Now the next it calls the check leap year program, so function. It will return 1 for true, 0 for false. Okay, then I have an if condition. If it is true, that is, then print it is a leap year. If it is not true, then it will print not a leap year. Okay, and then it will return 0. If here return a result will be either 1 or 2 for false. Okay, so let's check what is happening in leap year. In leap year, as I explained, first we'll check whether it is divisible by 400. Okay, is it divisible by 400? Yes, if it is divisible, that is modular of y modular of 400, the remainder is 0, then return by default it is a leap year. Now the second condition, y modular of 4, that is, if the year is modular of 4 is 0, that is divisible by 4, and it is not divisible by 100. Consider example 2004, modular of 4 0, it's true. 2004 modular of 100 is not equal to 0, that is correct, right? We'll be left with 404 when we do the maths. Okay, then it's also a true. Else if both these conditions are not holding, then it will be false, then we are returning 0. Okay, so let's quickly run this program. Okay, so to run this program, as I have explained in this, first we have to compile it, GCC compiler. Once it is compiled, we'll get the leap year.exe, so we have to run it. Enter the year. Let me enter 2024, the current. 2026, the current year. 2026 is not a leap year. So if I run it again, example 2004, 2004 is a leap year. So consider anything 1990, 1990. So I have to run it. Here 1990 is not a leap year. So similarly, so you can find out. This is a simple leap year program. Okay. Okay. Now we have what is scope. Scope defines where the variable is used. That is where the variable will be used. Okay. So there are 4 scopes: file scope, function prototype scope, function scope, block scope. It goes from big to small. This is file scope is big scope. Considering this will go down. What is this file scope? In our program, we declared it year, right, as a global variable. It can be accessed throughout the file in any function. That is the file scope. So it has this file scope. Global variables will have a file scope. Function prototype, if we see, we had a check leap year program, right? So that is the function prototype example, where it is defined in a function declaration. Okay, any scope that is defined within a function. Int res, we have defined is it main function, right? So that is as it is only applicable inside main function. So that is on that function scope. Block scope, anything that is declared within a block, that is a curly brackets, right? That is want to be called block scope. Okay, so file scope will be entire file. Prototype scope will be declaration only. Function scope is inside function. Block scope is inside the this. So in our program, int year is a file scope. That is the global variable. This can be accessed anywhere. You can see it is accessed in main. Here you can replace this y with year also. Okay. So that is, it can be put anywhere in this file. Okay. The function prototype scope is where it is used inside a function declaration. See, you can see into y is there, right? We have to pass this y value here. So this type of declaration, whatever, these will have access within the function. So these are called function prototype scopes. Okay. Then there is a function scope. See, int res is defined at the start of the function, right? This res is available within the function. So that's why this is function scope. Okay. Now consider if I had anything declared within this block. Int x is equal to 1. Okay, so that would be accessible within this block, not outside this block. So that is has the block access, block scope. So this is about 4 scopes and the leap year program. Hope you understand the program. So you understand the 5 types. Okay, we will now talk about type compilers. We have two compilers, two type compilers, const and volatile. Type compilers, what a type compiler? Type compiler specify how the variables can be used. Okay, it will tell the compiler a little bit about the variables, what type of variables. So let's talk about const compiler, const qualifier. Const means the value will cannot be changed. It's a fixed value. So it will never, it is only going to be a readme value. Okay, it is not going to be written. It is only once it is written at the time of initialization. Apart from that, it will never be rewritten. Okay, volatile is something where the value keeps on changing. Okay, in our previous example, year is a dynamic value, right? It will keep on changing. But 400 divided by 4 divided by 100, these are constant values. These values will not be changed. To calculation of leap year, this is the values. This cannot be changed. Okay, so okay, I have written a simple program to extend the type qualifiers. Okay, we have included yesterday normal here in main function. Here we have declared int max as 100. So I'm printing the max value. Then we have another field called volatile int flag 1. I'm printing the flag. Flag is equal to 1. I'm waiting and I'm making it a 0. This is a while loop. Okay, we'll explain about while loop but in our coming chapters. Okay, it will wait for this until it becomes while. Okay, let me run this program. So same thing, first I will compile it, then we will run the program. Clear it. Type qualifier setting. See, you can see max value is 100. We're waiting and flag changed, exit loop. So this flag has changed. This value can be changed. So consider if I try to change it, this value. So let's see what happens in that case. It is already showing me this one, but let's see what happens. So let me compile it. You can see there is an error. Assignment is a read value available. So that's how it will help you while writing a programs itself. It will help you that okay, this value cannot be changed, so I have to do this. So it should not be changing this value. Okay, if I comment this again, so let me show. Okay, compiler. So now it is running. Okay, so that's it for this topic. So we'll see you in next class. Thank you.